thanks so much everyone for coming down tonight, really appreciate it. You obviously all passed the first test, which is some numpty forgetting to put the proper address on the invite. So you're all very smart for making it here tonight. Thanks for not dying on the way over. So we've got a really jam-packed evening for you tonight. It should be a really good one. So I'm just going to give you a quick 5-minute introduction to WeShape and who we are. Then we'll get on to the actually interesting stuff, which is Luke, who's down at the front, talking about better GitOps for Kubernetes and Kubernetes packaging and beyond Helm, which is what I know you're all here for. And then afterwards, if you'd like to join us on our rooftop, which is why I'm sure some of you are here, we'll have some drinks and some pizza and enjoy the rest of our evening from there. So, for those of you who has anyone heard of WeShape before tonight? That's good. I'm surprised Glenn hasn't because you work here, so and you're wearing a t-shirt, so I'm hoping. But it's, no, so WeShape, apart from a big old spiel up on the board, we're a DevOps, digital, data and cloud native consultancy. We've been going for 2 years. What sort of stands us out from the others? So we are a hybrid model, so we're half ex-industry recruiters, and half technical consultants. So what that allows us to do is scale our teams rapidly, on demand, and put the best people against the best projects at scale. We're also behind 2 other events, so hands up if anyone been to London DevOps before? That's good, yeah. So a few of you might know Jack Moore, who's one of our co-founders, he's one of the co-organisers of London DevOps. We also run London Tech Leaders, which is our other event aimed at more of the C-suite technology leaders across London. So, as I mentioned before, we're a hybrid model, so half ex-industry recruiters and half technical consultants. Our tech consultants come from our associate network, so what we're really trying to do here is build the gig economy of DevOps, cloud and data contracting. So what we want to do is effectively build a talent pool full of people with technical subject matter experts across our core focus areas, all with a really consultative mindset and all who love what they do and want to work on the best projects. So if that sounds like you, do have a chat with Glenn, who's at the back there, Deanna Glenn, who is our talent acquisition lead, who would just love to talk your ear off all about tonight about becoming a WeShape associate. If that's not enough, I'm going to give you a few other top tips on why you should become a WeShape associate. So, as anyone who's currently a contractor knows, coming up to the end of the contract can be a nerve-wracking time. So we always give you first refusal on all of our up-and-coming projects. We have regular socials, so you can see this is the rooftop where we'll go up later. Obviously it'll be a bit darker then. That's my ugly mug there. And that's us having our quarterly consultant drinks. We're also taking all of our associates out this Christmas over to Swingers Golf Club for a round of golf and unlimited drinks, which will be fun. It's a big thank you for all their hard work. We pay referral fees, so again, good people know good people. You know a good colleague of yours, come on site, you can earn yourself a nice £1,000 once they've been on site for 3 months with us. We also do profit share, which is quite an innovative model that we do. So obviously all the good work that our associates do for us on site then means obviously, you know, they want to use WeShape more. If you bring WeShape on board, you then receive a share of the profit of that project. We have regular contact with all the core team, which unfortunately includes me and Glenn and Chris at the back. Again, top 5% tech consultants who'll be working alongside some of the best. Every 23rd of the month we pay, so again, for those of you that are contractors will know that, again, getting paid on time and consistently is a big thing. So again, every 23rd we do pay out. We have a really slick onboarding process. So I think the quickest we've done it is from someone first speaking to Glenn to being on site with one of our clients within 24 hours, so we can get things moving very, very quickly on to next. And you can also feel good, so we're B Corp pending and we're carbon neutral. So those of you who don't know what B Corps are, it's basically a certification that organisations that are high sort of ethical, environmental and social sort of standards held. So as you can see, again, won't bore you by reading these out too much, but we've got Rob Coward up on the top left, who's sort of, yeah, again, how much involvement you get with the core team, all the different projects, technology you get to work on, and that's a lovely Nur who's on site with us as a data consultant. Again, we do like to get involved, and both of these guys are always up on the rooftop with us for those quarterly drinks, having a good time. Again, so some of our projects that you'll be working on, so some of our projects in the past, so we've actually built a bespoke content delivery network from scratch, so that was a big sort of year-long project for a big client of ours. We've had a big retail client build out their digital pharmacy in Azure. No good for guessing who that is. We've created a replacement national security vetting website for one of our big public sector clients. and we built an open banking platform to support a fintech client. So if any of that sounds interesting to you, these projects are ongoing. We have projects like this all the time, bigger and better. So again, do talk to us about it. So it's the part you've all been waiting for, me to shut up and hand over to Luke. So you're Luke, is at the front. Luke's been with us for just over 2 years. He's been deploying multiple projects with us. Again, any questions on being a WeShape associate, I'm sure Luke will be happy to answer them. Again, CV sort of talks for itself. He's worked with ITV, Ministry of Justice, JFK. He's worked with JFK, not the president. He's worked, he's Kubernetes inside now, which you'll see some of that knowledge tonight. And again, he's done multiple workshops and multiple training sessions for us tonight.
Just go back to the title. I'm here to talk about Kubernetes technologies generally. Yeah, that's all I know. 2 topics I was asked to cover. It's based on a survey of apparently some of your answers, or maybe not. Let's talk about better GitOps and Kubernetes packaging beyond Helm. Now, me, as the guys were introduced, I work at WeShape a lot. I've been doing this for probably more than 18 years now, actually. I was a developer for about 10 years, Python, Java, C++, PHP. A lot of other things like that, but more recently, obviously, I've also gone into a lot of Golang. I've been working advisory, consultancy, planning, team formation, everything with the WeShape guys. And I'm a fan of sports, got everything I said, Kubernetes and peanut and nips because they're great. And I've had a rough week, so I could do some sweets. That is actually my hand, by the way. So I've had an injury playing sport, and it meant that a lot of my week was taken up in hospital consultations. So if this presentation isn't exactly glowing, I'm sorry, but hopefully it's okay. I was hoping to do code examples and things like that, but time did not permit with my limited availability and stuff. And perhaps we'll just start off with what we're talking about initially, GitOps. GitOps. So say it a few times as though we use all meaning, and GitOps, and then by the end of the talk, you'll probably feel quite a bit like Sam Jackson. So, what are we here to talk about? This concept of GitOps, what does it do? You put the definition of what your environment wants to look like into Git, and then by some miracle of science, technology and magic, it gets into your cloud environment. Usually, people start off with GitOps as a kind of like a continuous deployment of a definition of state of their environments. Their Terraform templating is usually your starting point to configure up their networks of VMs, maybe their clusters, whatever it is they're going to do. They might also do the same with Ansible for configuration management, and in the much more modern world these days, Kubernetes. And so kubectl apply type stuff in a CI pipeline based on what's in your Git repo. So that's all good and kind of basic, but hello, nice. But the one that we're usually more interested in these days is the container side of things. So pushing your container configurations into, I noticed this actually, for some reason I've used GCP icons for Kubernetes clusters, I don't know why. I do like GCP, but yeah, I just did. Anyway, so sometimes you might also do something clever like put Helm packages into it, so it gets a bit more interesting. So all this is just basically saying your CI looks at your Git repo, applies Kubernetes manifests, applies Helm charts and the packaging therein, and that's how it's usually done in at least the beginning. But this can get cumbersome. It gets heavy because you start saying, well, I need a Git repo for every environment. What if I have this array of environments? It's like, okay, I've got one version there, another version there, another version there, and I have a separate pipeline for each of those environments. And this can go way, way worse. And I think there's some things in my slides that should be leading into each other, but I can't see the upcoming slides, so I don't remember. Wouldn't it be nice if we get rid of all that weight? Let's get rid of this and sort of go, I don't want pipelines anymore because I have to maintain individual, whatever it is, GitLab YAMLs, Jenkins files, whatever horrendous tool like Jenkins you have to use. Or maybe you're lucky you get to use GitHub Actions, or something like that. But it's all extra maintenance, it's all extra overhead, and less please. And there's also multiple Git repos. I'd like one. I'd like there to be one in this scenario. So this is what we want to try and achieve. Get rid of all CI and just have that. So how do we do it? There we go. Operators. We have some candidates. in the world. There are probably more, but these are the two that most people have used or looked at. How many people have actually done GitOps here? All 90? Or have done either of these tools? Yeah, does anybody use them? No, you're all kind of new to this concept. This is good. It means that the intro level talk I'm giving is probably better. Okay, so Argo is an open source product. It has a sort of a heritage in initially a workflow DSL that was supposed to be able to compose jobs in Kubernetes and run them. And there are different components to Argo. One is the CD piece, which just has that GitOps-y kind of deployment methodology about it. There is a CI project, but it's a bit underdone at the moment. There's a workflow engine as well, so you can have kind of defined automations in Kubernetes triggered by different things. So it's got an interesting ecosystem of a project, a set of projects rather than just one project. But the most developed at the moment is Argo CD, which is the deployment one, the GitOps operator. Flux is from Weaveworks of Flannel fame and things like that. And it's had 2 iterations now on the second version, which in my opinion is quite a bit better, with one notable alteration, and it's limited its ability to trigger events after it does stuff. So, what we do is we stick an operator into each cluster, it subscribes to a Git repo, and whenever you want to have stuff happen, it kind of goes through this cycle. You commit into Git, the Flux operator syncs that Git repository, and then applies all the resources into your Kubernetes API, which deploys them all. And obviously, it can pull registries and pull from there. And we lose this nasty connection of allowing those filthy, dirty developers to touch your precious Kubernetes cluster, because we don't like their hands on things. In fact, we probably don't like our own hands on things either. So this is good. That's a good thing to get rid of. The next part. Flux has lots of components. I'm focused on Flux because, 1, I've used it more, and 2, I think it is better for explaining all the different potential moving parts that can be in something like this. So the main bits of Flux are source controller, customized controller, and the Helm controller. So source controller acts as your Git repo sort of polling tool. It will watch Git repos, poll them for changes, and then notify the customized controller, which is what does all the kubectl apply, except with a -k for actually running the customized layer on top of it. So it allows you to run totally standard kubectl type apply stuff based on what's in your Git repo, and then apply it into your environment, putting in namespaces or like deployments, Helm releases, CRDs, everything, every type of resource you can imagine. If it's a YAML file in your Git repo, in the folder it's told to apply from, it will just dump it in as a resource into Kubernetes. Customization gives you a lot of interesting powers though. It will allow you to sequence by dependency different folders of different Git repos. Different folders of your Git repo in terms of like collections of maybe like a component, a given service, an application, whatever it might be. Additionally, you can also reference, I haven't got actually on here, the Git repo idea is actually identified by its own set of CRDs. So there's a custom resource definition Kubernetes which says, this is where my Git repo is, this is how I connect to it with my token or my key or whatever it is. And the source controller then can pull the repo down and make it available through a shared volume to the customized controller. And then the customized controller can piece together an overall estate of all your applications, all your workloads through your cluster, based on the series of pointers and customizations to say, I'm a customization, apply all the YAML in this folder. There's another customization there which tells it to do other subfolders, and you can have all this dependency and hierarchy and layering, and it's quite clever. Now this is kind of standard across both. Argo can do it too, all the same customization capabilities. The main difference between the two tools is Argo is a little older. It's based on a monolithic component of just Argo, one big Argo operator, whereas Flux now try to decompose it out into smaller, more maintainable pieces. What it also means is there are a few more pieces, which we'll get into a little bit later. The last piece I haven't talked about yet is the Helm controller. Your customization can apply a Helm CRD, a Helm release CRD, which Flux also defines. and it will roll out, much like you just do a Helm upgrade-I or install or upgrade, whatever way you do it, to apply your Helm chart. And the source controller is also watching the target Helm repository CRD, not the CRD you create, which is a Helm repository. This would be great if I had lots of code examples for all this, but I don't really have that at the moment. But the idea is then that the Helm controller can just take over, deploy your Helm charts, really nice, and that's great if you want to use Helm. What else can it do? One of the things it has, which I haven't got on here, is it has a notification controller. So if you don't want a poll, you can send it up to receive webhooks from Git repos. So the notification controller tells the source controller, oh, there's something's happened, I've got a webhook. It goes, pulls, and notifies the customization controller if it sees diff, and then the whole sync operation begins again. So that's the whole nature of GitOps. Obviously, it's just like a idempotent syncing of state declaration to applied state, and good for configuration drift, avoiding change, all that kind of stuff. If you make a change manually, it will reset it, at least anything it manages. So that's all quite useful. So, what about continuous delivery? So continuous delivery usually is approached by this idea of the image updating in your Docker registry, your container registry. And if you get a new tag, it's enved later, all the rest, you can just say, well, I'm going to have these new components added to the Flux estate of components, an image reflector controller and an image automation controller. The two have different roles. One watches the registry for changes and sends a notification to the source controller to do something. Or actually, no, I think it tells the image automation controller what to do. The image automation controller has a piece which pushes the change back into your Git repo. So it actually rewrites the versions of the images that you're deploying back into your GitOps state so that it is recorded. There's an audit trail that happens. So we have a couple of examples here, code examples, yes. And I'll admit, I totally just ripped them off the documentation. So you start up on the left and you go, right, I need an image repository. This is what I'm watching for changes. So I just say, let's use the pod info one, that's easy. And then you have an image policy which says, well, this is the range of versions that I want it to look for. So if it's just wildcarding on the last component, you could do just latest if you want. You just do x.x.x or just x. I think 1x will actually do it. There is a documentation on Semver notation, all the rest in there. And then you put this image policy tag on the line in the deployment YAML for the thing you're trying to deploy. And you say, right, that's great, I've got my policy, I've got places looking for it, and this is the thing I actually want to have updated when something changes or has something, it sees something newer. And the last piece is, like we said, is the automation controller. It then sees that change happen. It will apply the change back into your repository, and the source controller will see the change, tell the customization controller to reapply the deployment with the new value in the actual in the deployment YAML. And as you see here, it has all these components like who's actually doing the work, so you can identify these are like automation controller events with a nice templating, sort of a bit Jinja-like, but it's actually good templates, I think. For writing custom messages, you can actually customize that. I've done some ones where I fed in extra information from another controller which was watching for for events from Flagger, and then re-annotating like this is actually rollback or roll forward because of Flagger changes or something like that. So you can do some integrations with other pieces if you're able to figure it out. But in simplest terms, it will just say, here's the updated images. If it does multiple at once in one commit, so it sees multiple image policies have all changed at once, it will write out a list of them, and then do one atomic commit, which is hopefully a good thing, in your opinion. And obviously tells which branch to go back to, and the path that it should apply the image policy to. So, so that explains the code bit, and I suppose, yeah, I really just had that there to talk through the sequence of events again, but I guess we don't need to, we've just done it. Yeah, okay, cool. Does that make sense? Yeah, go ahead.
So it actually pushes it to the repo with a commit message, which then is picked up by Helm controller rather than speaking directly to the Helm controller. Is that right?
No, source control. So
It pushes the source instead of directly to Helm. Helm picks up from the source controller to actually apply the change.
Helm picks up from the Helm CRDs, which are written by the customized controller. Customized controller is the one that gets updates from the source controller. I guess there is connection there. I never know what the communication is. Yeah, that line might be a bit misleading. The only place where this might be the case is when it's asking for the Helm chart,
Okay.
not the Git repo. So, or a Git repo where the Helm chart is stored. So I think that's the concern for that. Like, it's not about
So are you saying it writes back to the Git repo?
yeah, for your GitOps state Git repo, not where the Helm chart is necessarily. There might be a way to do that. You might be able to write back to a Git repo, which can store the chart by using an image policy in your Helm chart, which would be really dangerous. But you probably do it. Yeah. So to follow the flow of events, that's why I put that there. I guess, yeah.
Like, what about test suite integration? Like, how do you confirm that everything is working fine?
It's a good question, in fairness. Different ways. Most of the time, you have to rely on either CI, sort of build time testing, maybe there's things like binary authorizers, which can have metadata around packages to say whether or not they're authorized to deploy. If you're worried about roll forward, roll back, you can have liveness probes and test phases in your Helm chart, say, to say whether or not something is deployed, or a liveness probe just in a deployment. That deployment affects the status of the customization. Customization acts as kind of like the top level artifact for Flux, saying if something within this customization fails, it does trickle back up to the customization to say that failed. As long as you wire up your probes correctly to tell the customization that it fails. And then the other piece is then to rely on things like Flagger, there's a great tool which I'm really interested in trying called Captain, which I haven't put into this talk, but it's an interesting one. It relies on, a bit like Flagger, relying on metrics. It has a bit more of a CI mentality around incident resolution. So it looks at metrics in your Prometheus and then the status of deployments and all these other types of things, and when an incident is raised, it can actually have formulaic resolution actions, which might be rollback, it might be calling out to your Jira system, raising tickets, it might be whatever. It has like a batch job type approach. So Captain's quite a cool tool actually. But Flagger would be the other one where it just sort of goes, here's a canary kind of release process or an AB or whichever kind of way you want to do it. If it fails, you have to roll it back. And then failure mode stuff like that, it should tell your customization it failed, and then it just goes into a failed state. It doesn't write back to your Git repo to say that failed. You just have to then pick up the events. That's where things like the notification controller come in, and appropriate Prometheus metrics all exist for the status of your Helm. You can get a Helm exporter component controller that sits in a cluster which will report the status for your Helm charts. So there is an awful lot of a gap in a way from this tool's point of view in saying I can take care of validating your deployments. So I think that's something that just continues to depend on exactly what tool you want to use and how you want to go about it. A lot of these tools try not to be all encompassing and all answering and all singing. They don't like monoliths, it's all microservice based, and then it's a case of, well, I can swap out one module for that purpose with another, easy. You know? And everything is as close to Kubernetes native resource definitions as possible, so that everything can interop correctly through the defined APIs and not have any bespoke integrations you have to worry about. Everything acts as if it's just part of the Kubernetes API ecosystem, and that's, you know, a safe way to go. Right. Anything else on that? Right. What are the shortcomings of this arrangement? So I think probably add that one to it. It doesn't really cover deployment failure cases. I put in Helm charts don't necessarily update automatically themselves. You kind of have to explicitly set Helm chart versions. It won't do that sort of policy update concept. The customizations for multiple environments. So you can have, I think actually if you go back a few slides, you can see here, it has this path, and when you bootstrap Flux, you tell the path in the Git repo to look at for your cluster's workload definitions. So you can have multiple clusters in one Git repo. that's where trying to get to this model makes sense. You have one Git repo, different path for each environment that you want to deploy, and each one is an entry point of a set of customizations. So your customizations can reach out behind that folder to other subfolders, or even entirely other Git repos, and include all the workloads you need for that environment with customization overlays, patches. You know, if you've done Kustomize, are you guys familiar enough with Kustomize? Have you used it? No. Okay, so it acts as like a I'd have to explain Kustomize. Kustomize is like it was a separate tool, but it's very much bundled into kubectl now. It acts as like a manifest overriding. It's like templateless layering in a way. It doesn't do templating, it does layering. So if you need to change a version, you could have it as a customization overlay. So you could say, I pointed a different image for this thing, or you need to change the URL of an environment in an environment variable for a dependency. So you do that per environment. Then with a customization, that you're changing it out. Whatever it might be, there's lots of uses for it. But when you do get into separate environments, it means that you start having to maintain customizations that are particular to each environment. Customizations are great if you want to do things like add a global label across lots of stuff in one environment. You do a customization and there's that one label. But if you need to change the credential or the key or something like that, or a secret for an environment, customizations aren't really going to give you that. They'll give that, but you end up having to maintain a whole load of customizations for all that. So it can get messy and complicated if you're trying to customize components in separate environments constantly. Where was the other? There, let's go back. Yeah, fan out implementation. So say you have multiple customers with separate environments, which is one of the ones I think I want to look at specifically tonight. It can get real messy because you end up having all your different environments as separate folders in one Git repo. You don't get sort of blast radius protection, and it's isolation of data, and it's potential leak between things. It's not great for that. And what else? Bad diffs. So you've got your image automation policy concept. It writes back to the Git repo. In each deployment.yaml, where you've put in the image policy thing, your diff looks like 17 different files because all these different images have changed at different versions. And the diff is distributed across lots of stuff. So most people would say, oh, that's just how you do GitOps, right? Well, I don't want to do it that way anymore. I want to change. So what we have is that arrangement, the one Git repo to lots of environments. What if this is the client's example? So say I've got my 3 personal ER development environment stuff, but then I have to promote it to my clients. This is a scenario I've seen time and time again. People who are developing a platform which is almost like packaged software that lives on top of Kubernetes. And they end up with this scenario. So, well, we develop it here, but then we have to transcribe the entire platform configuration to another Git repo for the next client, and the next client, and the next client. Oh, there's updates, there's a new version of the platform, which has new components, new deployments. We have to now update all these different things. It gets really difficult to manage. And you've got pipelines for each one, and it's a bit of a mess. So what do we do? I like this tool. And this is one solution. I'm not saying it is the solution. I'm saying it could be a good one. Capitan is a tool which combines hierarchical data and templating to render outputs to whatever you want. It doesn't have to be Kubernetes YAML files. It could be Terraform. It could be anything. Ansible, configuration manager, who cares? It's just a big, clever templating engine. One of the other things it does is it integrates secrets management. So it can talk to AWS KMS, GKMS, vaults, various other things. And it uses a clever placeholder mapping tool. So when it renders this template, it doesn't unseal the secrets. It writes them as a reference to, say, a GKMS key. Then when you actually deploy it, you can have either just a Capitan unwrap, reveal, sorry, that's it, Capitan reveal, and it will dereference all of those references and make them the actual values in YAML at that point. You can do that as an operator. There's an operator called Tesoro, which can live in your Kubernetes cluster. When you apply the manifests, which are a result of a Capitan render, it will see the references and you have a policy annotation system for it. And it will unwrap those references based on its KMS connection and just as a mutating webhook. So when you deploy something, Kubernetes will catch the incoming resource you're trying to deploy, unwrap the secret, and then it's actually a real secret once it gets on there. So I think that changes the story a bit. I no longer have to maintain one plus n number of different environment Git repos. I maintain my Capitan template repo, and then through some kind of operation, the templating just gets re-rendered out to all the other Git repos. Some of the things that make it really, really nice. The whole environment configuration is versionable, so I can have version 1, 2, 3 of my entire platform. And if I'm rolling out to multiple environments, then the one environment could be at a different version, and I can explicitly decide when to promote that configuration change. Because I think that's the biggest shortcoming in GitOps at the moment in the standard tooling. There's no such thing as configuration versioning, as in tagging, as in saying I want to have outside of the GitOps repo itself some way to say I'm going to uplift this to a new version altogether, because the architecture of my entire platform has changed. So I think this is one way of doing it. There might be other ways, but I think this is definitely one way. Environment variables. So you want to turn on and off features, add dependencies, or set dependency URLs, or set the versions of the images for your deployment. You can do it as environment variables in the Capitan templating engine, and render them into your deployments. That way you have one single place where the diff matters. You just set your changes there, and they render into your GitOps repo. One idea I had was you could set the Flux image automation policy to look at the versions in the Capitan templates and have it do the image policy updates back to Capitan before it re-renders your deployments out to Flux. So you could close the loop that way, and it could be quite a good way of doing it. Yeah, it gets rid of the customization mess, because you no longer have to worry about turning things on and off, customize overlaying. It's all rendered by a template now, so you don't need it. Automation for repeatable deployments. Like I said, you're not having to transcribe Git repos and deployment YAMLs. It's now just repeatedly rendered as a job. Can also be used for the other layers, like I was saying. It's the what if I have versioning of my Terraform based on which environment I want to go to and overrides. That's less of a problem for Terraform. There's workspaces, there's TerraGrunt, there's lots of tooling around that space. But it's, if you want to centralize in one tool, it could be useful for both of them. Certainly with like configuration management or anything like that. Although most of them also bring in these kind of layering tools. But once you sort of unify, say, all your environment configuration values into one place, it means that configuration in your Terraform, in your Ansible, your Puppet, your Salts, whatever you want to use for configuration management, and your GitOps Kubernetes deployments can all feed off the same values, the same hierarchical data set. So that could be incredibly powerful. Yeah. The only downside might be, in my exact architecture, is you end up with a central CI that's pushing out to all the environments. I have thoughts on how to do that better. It might involve making an operator out of Capitan that lives in clusters that self-render their own templates, but that's to be done yet. And obviously, open to suggestions. Are there any other problems anyone else can see? Because obviously, I'd love a critique. So that's that topic, and now on to this one. What time is it now? I've done half an hour, have I?
Go as much time as you want.
Yeah.
And then I think
Thankfully, given my circumstances, I haven't had as much time to spend on it, so I'm going to keep it quite short. Helm packaging. Words. Ooh. So it's good in some ways. It's atomically changes the package. So you take an application, you change the version of the Helm chart, the whole thing is there. Abstraction of your components from the environment. So in that platform story, you have, this is the list of components I want, but I don't have all the manifests for those components fat out in my base level template, and that means they're easily replaceable. You just change the version or the URL for your Helm chart, or the actual Helm chart for different application stack, and it's simplifies your underlying platform template if you want to do it that way. Yeah, you can have versions linked to your container builds. A lot of applications, if they're in-house development, they'll have their CI pipeline, which builds a Docker container out of their actual application code in their CI pipeline. And adjacent to that, they can also have the definition of their Helm chart in the same repo and push that Helm chart out to whatever storage you're using. And that means that you can synchronize the version of the Helm chart to the container version, and then you don't have to worry about actual continuous delivery of actual images if you don't want, if that doesn't suit you. And you can rely on Helm charts as your actual versioning. But that might negate sort of automatic deployments like we're talking about, unless you find some way to do that with templating, say. What else is good about it? Yeah, so the interface kind of stabilizes the definition of the inputs into your actual application. It's not just deployment of environment variables, it's your deployment, maybe config maps, your service, your ingress, your domain name, or whatever else it is you need to define in your application stack, and all the different components that need to live in your Kubernetes deployment along with it. And extremely widely adopted, yeah, CNCF supported. It's a CNCF project, hosted project. They definitely, it's been there since the beginning of Kubernetes nearly. And the ecosystem of off-the-shelf components is vast. It is so big. There are lots and lots of great things packaged up in Kubernetes, in Helm. It's gotten a little bit trickier lately. They deprecated the central shared repository of all Helm charts, and it's gone into lots of self-hosted ones and ones for particular companies. And fragmentation is great, right? And subchart capability, code reuse. You know, you can have a Helm chart, you can require a subchart off it, and you get like, say, a database on the back of your Node.js app or whatever it is, and it's a subchart of standard Postgres deployment is easily referenceable if you want to use it that way. So it's kind of good. But what are the downsides? It's a bit of a black box, you know, dark magic. You don't know what's in there. And you have things like vendors changing their Helm chart from version to version out from under you. You don't know what's going to happen. They change the values, they change the mapping of secret. You know, they just surprise you. You know, they think it's a gift. You know? So this also limits the visibility in terms of, if you say you're doing GitOps, you want to see what's actually changed deployment to deployment. You get no audit trail. You just have to look into the Helm chart and diff the previous one, and oh my god. You know, so that's not great either. Image policies can be difficult to integrate. So if you're doing that automated image policy update concept, you can't really reach into anything other than the values file and try and pass in an image override to change a version. And it can work, but it may not be as easy to integrate. Yeah, configuration interface defines your values, so you don't know what the hell is going on behind the interface. So again, it's just all this like blocking off. Till there was a problem, Helm 3 has helped, definitely, it's a lot better.
I like Tiller because you know when you're reading a thing off Google that's out of date. It says Tiller, you're like, no, I'm not reading that.
It's a great indicator, isn't it? Yeah, it's like, oh, this is not relevant anymore. Great, I can leave it. Yeah. The only problem with it, of course, is there are endless companies out there who are stuck on legacy Helm 2 deployments, and you go into companies and go, oh, great, you know, we've got that problem. By and large, people are usually pretty open to, you know, upgrading, and that's okay. There's a great plugin called Helm 2 to 3, which does a great job of migrating existing Helm 2 to Helm 3. It's really, really good. I've used it in automation, sort of progressive rollout of Helm 2 to 3 within environments, and it's done a great job. So it is a fairly solvable problem. And negative, subchart capabilities. They're a dependency liability. Your application might depend on another application, and then they change that one on you, and oh my god, my application doesn't deploy anymore, but I didn't change anything, this is bad. So, you know, a little side to that. But that's, you know, much of a muchness. And short storage and maintenance liability. I've been in environments where they had 150 different microservices, maybe 200, and every single one of them produces Helm charts. And not just the production deploys, every commit. And they dump them into an S3 bucket. You have somewhere in the region of 400,000 Helm charts in an S3 bucket. And they're using the S3 adapter for Helm to talk to S3. Oh my god, the reindexing is a nightmare. It's just awful. So, you know, there are things it adds complexity to your environment, to your pipelines, your management. There's things to worry about there. Maybe you use Chart Museum or something with better indexing, or like Artifactory or something that can host your Helm charts with an actual indexing service behind it. But again, I just talked about a whole bunch of new services you have to run, so that's tricky. These days, most of the registries, like ECR I think does, and Google Artifact Registry, are all OCI storage, and it means they can store anything, including Helm charts, which is cool. So you can do Docker containers and your Helm charts all together. Very nice. I did wonder if that was an avenue for folks to look at to start being able to pull Helm chart versions if they're in a registry with the same APIs. Surely the source controller can do that querying, and then you get automated Helm chart upgrades if you want to do CD of Helm charts. So that would be nice. What else? Yeah, so that's that. So some ideas. How do you get around those negatives? You could go to the GitOps manifest flat route, no charts, and just have it all there. It's all visible, it's all fat and written out. That could be good. You could render those charts into that Git repo so that you use Helm as a templating engine, not as a deployment tool, and render them into your GitOps repo up front and get around that. Or you could just enjoy using Helm PA options. But I think there is something else. There's a really cool new thing called crossplane. I don't know if anybody heard of this? You've heard of it, I can see you nodding. Yeah. So, what is crossplane? Crossplane is a really cool way of using application YAML manifests, deploy your application deployments in terms of Kubernetes, and having a cloud provider in your Kubernetes cluster that can talk out to your cloud resource, your cloud environment. What it does is you deploy a cloud provider for your environment you want to run with, or multiple environments if you like. That establishes a bunch of API namespaces in Kubernetes, which allows you to create custom resources to say, I want an Amazon ELB, I want an S3 bucket, I want an RDS instance, I want whatever. GCP, same thing, Azure, same thing, and a few others besides. I think they do Alibaba now, actually. There's loads of providers being generated, and it's constantly being built. Downside, it's kind of new, bit crazy, but what's lovely is you start looking at it in the context of our stories of GitOps and Helm charts and things. Oh, I think I skipped one. Oh yeah, that version. And then I said, why don't we put Helm in the mix? So in the default state, you do your Flux GitOps process, and it spits out Kubernetes resources and some CRDs, which Crossplane uses to generate your cloud resources you need. But obviously, yeah, if you put Helm chart, your application will be in Helm chart with all its Kubernetes resources, bundled with also its dependencies it needs in the cloud environment. Your application needs a database, there's an RDS CRD, it'll create one for you, job done, really handy. Means you don't have to put all that infrastructure dependency management back in your Terraform layer that you had to do earlier. So you don't have this fragmentation of responsibility, separation of concerns of infrastructure and application. The whole thing is now, in a way, its own package. And it does a lot more besides, but that's just the use case I'm really liking the idea of for Kubernetes. I think they're looking at it as a holistic way to package up applications, artifacts, everything into a registry. So it uses OCI registries to store, it could be static assets, tarbos, Helm charts, whatever you want, containers as well, and have them all referenceable through resource definition and control plane so that it can then take over deployment. Lots to learn about that. I haven't used it in Angular in an application yet, but I think it's a really interesting possibility. I've already messed with the cloud resource side of things and putting an application dependency behind a Helm chart. That's all I've done so far with it. But it's pretty interesting. There we go. So I think I've done just 40 minutes. But I think that's long enough for tonight.